Hello and welcome to Restoration DIY. It's great to have you here and I hope you enjoy the video. In this episode I'll be making a segmented bowl utilising the Ortur Laser Master 3 to cut through segments to make a feature ring. So without further ado, let's get into it. To create the feature segments, first I drew up a pattern in CAD. The pattern was split into two parts. The first was a simple engraved outline of the segments, the second was the actual pattern to be cut. Both files had the same 00 home point, so they lined up perfectly when I imported them into Laser GRBL, which controls the Ortur Laser Master 3. So this is the Ortur Laser Master 3. I've already engraved the outline of the segments on the piece of oak, which is 20mm thick, and now it's cutting the patterns, on its first pass of 8. The settings used were first for the engraving, 1000mm a minute, M3 constant power at 100% power for one pass, and the cutting settings were 100mm a minute, M3 constant power at 100% power for 8 passes. The video is playing at normal speed. Each pass took around 14 minutes. Times that by 8 and it took just under 2 hours to complete the cut. And I'm still cutting without air assist. Having it might help to reduce the time, but until I've tried it, I'm just speculating. Okay, so let's speed things up a bit, and I'm not going to make you sit through all 8 passes, so let's skip through to the end of the last one. As we come to the last few cuts, I'll go through a few things. First, it's important not to move the workpiece. The laser cut line is around 1/10 of a millimetre and you'll never be able to realign the cut. Also, I'm using a honeycomb cutting plate. This is great. It has a solid steel sheet under it protecting the workbench, and when the laser penetrates through the timber, it can easily be seen in the voids. All done. After removing the workpiece, I was surprised to see that the laser hadn't cut all the way through. From around the 6th pass, I could clearly see the laser in the honeycomb voids, but with no way of realigning the laser, it would have to do. Some did push out. For the others, I tried to finish cutting with a utility knife, but that was no good, so I resorted to using a small drift to punch them out. I was a bit nervous using the drift in this way, but after the first few successful taps, I could see there was hardly anything holding the waste pieces in place, so I carried on, and with a quick swipe round with a knife, I soon had all the holes cleaned out. Satisfied the feature patterns were done, I moved on to cutting the segments. For this project, I need to make 4 superiorly segmented rings and the feature ring, each one containing 18 segments. This was done on the table saw using the mitre jig set to 10 degrees. 3 rings for the lower section and the feature ring would be the same size. The 4th superiorly ring would be for the rim and the segments needed to be bigger. To calculate the segment sizes, I used to draw the project in CAD, and in the plan view I could work out the sizes required. I still draw the projects in CAD, but I've developed an Excel spreadsheet. Using formula in each cell, I get the required dimensions for whatever diameter ring I'm making. In this case, the lower rings have a diameter of 190mm, divide the circumference by 18 is 33.2, allowing for a 2mm joint and rounding down. Each segment is cut 31mm on the long side. With all the superiorly segments cut, I moved on to cutting the feature ring, and this is where the engraved lines came into play. I'd kept the piece of oak as square as I could to the Ortur laser frame. This meant I could set the table saw fence to accurately do the first cut, then I reset the fence to the correct height, and after another cut, I had a strip of segments ready to go. Carefully aligning the first engraved line with the edge of the mitre jig, I could do the first angle cut. Then aligning the next line and setting the fence, I could do the next one. Rinse and repeat, and I had all the pattern pieces cut. I'd originally wanted to do 18 pattern pieces, but that would have taken more time than I had. So whilst the saw was set up, I also cut 9 plain pieces. This is the first time I've done it like this, and it worked out very well. I'll be doing another quite soon, but I need to make a shorter jig to act as a fence. That way I can remove the standard aluminium one. The segments tend to pile up and occasionally get trapped against the blade, which can have interesting results. After sanding, I got on with assembling the rings. I used a 3D printed template. I designed this for creating rings with 2mm joints between the segments. It's easy to use. The 18 pieces are loosely arranged to form a circle. I hold them in place using an elastic band. Then I use another 3D printed part, a 2mm thick ring with 18 2mm prongs on either side to fit into the joints. There's also a single-sided version for the top and bottom ring. The spacer is pushed into the joints. It takes a bit of doing, but once it's seated and the elastic band is in place, I use super glue to bond it all together, being careful not to get any on the big template. With one side glued up, I flipped it over and removed the joint template, then added a single-sided joint spacer, glued in place with more super glue, using an activator to cure it faster. First ring done, the second was much the same, but this time I only glued one double-sided spacer to the segments. Once the superglue had cured, the template was removed. I had to re-glue a loose segment, then the two rings were pushed together, using a double-sided spacer to keep the segments aligned. Getting the two rings to line up takes a bit of doing. I found it's best to get a few adjacent segments seated, then I work my way around until they're all in place. The white spacers slotted into the gap holds the segments apart until the glue cures. That's two done, just one more for this lower blank. I tried something a bit different. I assembled the third ring on top of the other two. This was a bit of a risk, as I had to apply super glue to the joint spacer, making sure I didn't get any on the larger template. I worked my way around the template, gluing each segment in place, and in the end it all went very well. Everything lined up, and I was able to remove the template when it was done. A single-sided joint spacer glued in place finished it off, and one of the segments fell out, but it wasn't a problem to add a bit more glue and stick it back in. quick test fit in the silicone mould, and then it was on to the next ring. This one was for the rim, slightly bigger than the previous ones, at around 250mm diameter. I didn't have any joint spacers that were big enough, so I used mixing sticks, super glued on to hold it all in place. I think you get the idea, so I'll skip through to the next bit. That's the rim done. Next I did the feature ring. The segments for this were thinner and taller, so I stacked 2 joint templates to provide additional support, along with an elastic band to hold them all together. Cut down mixing sticks and super glue were applied to the top, and after the templates were removed, more was added to the bottom. And with the second lot glued in place, that was it done. I got the 3 blanks ready for resin casting. The lower blank had a big void, so I turned a piece of oak down, which allowed for around 1/4 inch gap to fill with epoxy. I was hoping to expose this in the pedestal base. The epoxy resin is my favourite brand, mixed at a 2:1 ratio. For this project, I used 3 batches, each one mixed for around 2 minutes. The chosen colour was purple. I stuck with one colour because there wasn't a big expanse of resin. After the mixing was done, I poured the resin straight into the castings. The only thing here is that I poured it slowly to try and prevent any trapped air voids. Then it was straight into the pressure pot. I stacked all 3 castings, placing weight where needed, screwed the lid down nice and tight, and added 50 to 55 psi and left it overnight to cure. It's the next day, and with the blanks removed from the pressure pot, the results look good, with no visible cracks or voids. Once the blanks were free of the moulds, it was time for the drum sander. Each one was passed through multiple times to level and flatten them. And this is where I realised I'd made a bit of a mistake. I'd hoped to leave a layer of resin on either side of the feature ring, but it was full of mixing sticks. I did what I could, but I resigned myself to the fact that some of the sticks might be visible in the finished piece. The technique I use with this sander is to keep the cuts light and the speed quite low. I also rotate the workpiece as much as I can. If it's not going through level, I can hold the blank and pass the thicker part through the open end of the drum, then continue as normal. It's a bit of trial and error, but I always seem to get good results. Sanding done, I could get on with some turning, just the base. I wanted to get this balanced and to round, to make it easier to line up the joints on the other 2 rings when I glued them together. I would also be able to check the joints to make sure they were parallel to the base. The Easy Wood Tools full-size finisher was first up, removing the bulk of the waste to uncover the segments. Then I switched to the bowl gouge to bring the base perpendicular to the side of the blank. And with the last little bit removed, I fixed the blank in the coal jaws, then I could cut the mortise. The mortise was cut in the usual way. First the 1/4 inch parting tool to define the outer edge, then I removed most of the inner material and cut the dovetail with a dovetail cutter, then a quick clean up and the addition of some embellishment. Then I sanded just the underside to 800 grit and added a finish, topped off with Hampshire Sheen gloss finishing wax. All done. I fixed the chuck in the mortise, centering it with the tailstock, and it was ready for the blank to be glued together. For this I mixed rapid setting epoxy resin with purple mica powder. This was applied to one side of the feature ring, which I then glued to the underside of the rim. I left it for 10 minutes or so for the first joint to set up, then mixed a second batch for the next glue up. Same again, rapid set epoxy, applied to the underside of the feature ring. I placed the heavier lower blank on top and carefully aligned the joints. It's 30 minutes later. I fixed the blank to the lathe, wound the speed up to around 800 RPM and set about turning. First to go was a full-size carbide cutter, fitted with a negative rate cutter. I used it to remove the excess resin covering the segments. I was keen to see how the patterns would look in the feature ring. I half expected to find some voids, but there were none. The resin-filled shapes were very well defined with very crisp edges. Happy there wasn't any voids to fill, I began shaping the rim. And sorry about the shaving obscuring the view, it'll disappear shortly. Taking the 3/8 bowl gouge, I cut away the underside of the segments using push cuts and shear scraping to gradually refine the shape. I wanted a fairly tight curve to transition from the rim into the side, so I used the mid-sized carbide. This has a standard cutter in it, so care has to be taken. It rips away at material at an alarming rate, so light passes were all that was required. The underside of the rim was more or less the shape, so I moved on to the cutout. This was always going to have a pedestal. In a previous video I said I was going to move away from doing this type of bowl, but I like them, so I'll keep doing one every now and then. Using the bowl gouge, I worked my way into the base, removing material on either side of the cut. And as I did, I noticed how the resin joints parallel to the base got more off centre. This didn't matter so much as most of it would disappear. And anyway, there wasn't much I could do about it now. The 1/4 inch parting tool helped to remove the deeper part of the cutout. To be honest, at this point I was in two minds about exposing the resin in the core. I was worried that it would weaken the base and perhaps snap whilst I was shaping the inside of the bowl. Whilst I had to think, I added a curved blend in the upper and lower cuts and reduced the size of the base. Then continued removing material, but in the end I decided to cut down a bit further. Taking the parting tool, I carefully removed what remained of the sapele segments covering the core. I was pretty sure it would be okay. After all, there was a big piece of oak straight through the centre. combination of the bowl gouge and the carbide cutters took care of finishing the outside shape of the bowl. Rather than having a flat face to the resin core, I softened it out, adding a gentle curve with the mid-sized carbide. The edge of the rim needed a bit more work to remove the last bit of resin, and with that and a tiny super glue repair to a small hole, it was done. I sanded the outside up to 600 grit and moved on to the inside. Because of the way I'd cast the 3 blanks, there wasn't a lot to take out of the inside, though when I began with the mid-sized carbide on the lumpy cast face of the resin, it gave me a bit of a fright when the blank came loose in the chuck. Luckily I had the tailstock in place so the bowl didn't fly off, and after a quick retighten, all was well. Access was a bit restricted with the tailstock in place, so I had to use the side of the carbide cutter to remove the resin off the midsection. But when most of it was gone, I started blending the rim down into the side. Switching to the full-size carbide, I began blending and fairing the inner surface, creating a sweeping curve down into the base. The transition between the side and base was a bit sharper than I would have preferred, but it was a case of working with what I had. I removed the tailstock to finish the bottom of the bowl, and it gave me access to use the large negative rate scraper to refine the surface, removing the last of the tool marks. And after a final go with a skew to tidy up the rim, it was done. Then I sanded from 80 to 800 grit, picking up the outer surface where I'd left it, then continued up to 3000 grit to remove all the scratches from the resin. Sanding done, I cleaned down with denatured alcohol. Followed by 2 coats of sanding sealer, each one de-nibbed with a non-abrasive Scotch pad. Next up, Yorkshire grit. A single coat thoroughly cleaned away till no more residue is picking up on the paper towel. Then the resin polishing, beginning with Merkur Polar Shine 10. A single application, thoroughly cleaned away, ready for the next stage. Polar Shine 5, another single application, buffed to leave a deep shine. And to finish, Hampshire Sheen Gloss Finishing Wax, 2 coats, polished off to seal and protect the surface. And that's it, another project finished. A welcome return of the pedestal bowl. This was fairly involved, with a lot of effort behind the scenes doing the CAD work and getting the correct settings for the laser, but it was all worth it in the end. The results look great, and I hope you like it too. The feature midsection came out so much better than I could have hoped for. There's still a bit to improve, like mixing sticks in the resin joints. It's a learning process. The next one will be better. Anyway, with that said, I'd like to thank you all for watching. Please subscribe, a thumbs up will be much appreciated, and comments are always welcome. I'll see you in the next one. Goodbye for now.